Cool. So again, if you do want to run this locally and try to install it locally, meaning you don't need an internet connection, you can still already do whatever you want on your own computer. You're not using Google's software and stuff, whatever, right? You can always download and get started with Anaconda. We're not going to go through it. They have good documentation of how to download it and get started, though. One last thing in terms of tooltips here. As you can see, right, this is a cell-based notebook. By cell-based, I mean, it's kind of like a spreadsheet, right? It's just the width is one cell as opposed to, you know, whatever, right? Usually an infinite number, technically. So here I have 3 cells, right? These have just text comments that show up as green, which are just annotations for y'all. To run a cell, there's a bunch of ways you can do that. You can click this play button. There's probably another button up here somewhere, but the easiest way to do it, to run a cell, you just hit shift, whoops. You can hit, not tab, shift plus enter. And it will run the cell. Here, there's not really code to run. It's just a comment. So we'll just kind of process it and show it to us. You know, in 15 seconds, when there's actual code to run, we can run something and hopefully get some sort of output. All right. So again, if you've encountered Python or any other programming language before, anyone in the chat, anyone encountered a programming language before? And by encountered, I mean like used it enough to have, you know, done something meaningful or useful with it. Most people have encountered something via MySpace or whatever a lot of the time for people. We got one C++, that's fair. SQL, all right. C++, a lot of people have seen C++ at some point, partly from school, or you're just old school, which is also fair. Cool. So there's a lot of Python, C++, JavaScript, very cool. So in most programming languages, right, we have a bunch of ways we can represent data. People think that it's a lot of math-based stuff. And for data analysis, data processing, that may be a little bit true. It may be a little mathier than other programming, but honestly, a lot of it becomes not 100% math-centric, honestly. It's not all calculator stuff. A lot of it's different. So, but one of the data types, right, meaning type of data, right? If you've used a spreadsheet, they're very similar, right? You've got text, you've got numbers, a few different kinds. There's other ones built into Python. We'll probably just stay with numbers and text for now for our data. All kinds of stuff though. Python has a way to represent all of them, right? So we can start out with a number, right? For example, 4 is a number, just as good as any other number, right? If I run this, you see that we actually get this little printed text output at the bottom. This is what we might call, this is the output that the notebook is showing us, but in Python terms, right, this 4, this is an integer, right? So the integer 4 is, you know, it's a number, right? It has no decimal, it's just the number 4. And this is Python's representation of it. Technically, the way each of these cells work is it takes whatever code expression you give it, which could be as, there we go. It could be as, you know, long or short as you want it to be, and it will run and execute it and then give you our output, right? 4 technically is an expression. It's one of the simplest expressions, right? Its value at the end of the day is just 4. Right, so we're kind of there with 4 already. We can always do more complicated things, right? For example, I assign 7 to the variable name a, right? So now I can use a to reference the integer 7. I add something to it like a plus 5. Right, this is a more complicated expression. We have 12, right? 7 plus 5 is 12. quick note about the notebook, right? You can technically, each cell can be as long as you want, right? You hit shift and enter or shift and return to run each cell simply because you can use the enter or return key normally to make a multi-line cell, right? So I can group a lot of code into this cell if I want, run it all at once, as opposed to running it line by line by line, single lines, which would take a lot of time and effort, right? So a lot of related stuff I can do, but simultaneously, unlike a script of code, right, where you kind of run the whole thing and the whole thing happens and you have no say in what does or doesn't get executed except for the code you already wrote in it. The notebook just runs cell by cell, but it also saves the state of everything in your notebook every time you run a cell, which means that even though this notebook isn't like currently running, I have reference still to A, right, which is still 7. All right, which means you can keep running little bits of code and doing little things, and your browser will store it all in its memory such that you can kind of have a safe way to both preserve all your old code, but also preserve all of your outputs over like a long span of using your notebook, right? Like a few hours or something, depending on how long you're working on a project. Obviously, this won't last forever, right? The next time I close and then open it, I'm going to need to run all my notebook cells again, but that's fine, right? It doesn't take that long, hopefully, to do so. And if it does, you might want to have like multiple notebooks or something a little fancier going on. Otherwise, right, Python supports, for those of you who haven't encountered too much Python or programming before, right, Python supports a lot of basic operations. For example, we can, we saw addition, right? All of the normal mathematical operations do exist with usually pretty predictable signs, right? This is 8 divided by the floating point number 2 gives us 4, right? 8 divided by 2 is 4. The difference is technically this is what we call a float, right? It has a decimal point, as 2 did. They behave the same in Python basically, but technically they're different types. So as an instructor, I'm obligated to mention it. There's also a lot of really built-in helpful functionality in Python, right? Python's known for having a huge standard library of already written code that does all sorts of things. For example, there's a round function. It rounds an expression. And this is one of the first places to note that when you use things built into Python, or in a second, one of the data analysis libraries we touch, the notebook environment is very helpful. It pops up with cool stuff like this tooltip, which basically tells you what the round function does, right? It takes a number, then a number of digits as 2 arguments, and it will round a number to a given precision, right? So like round 8 point something to 2 places, right? So rounds takes, let's give it an expression. I'm going to say 8 divided by 3, because that should be a weird decimal of like 2 2/3, I think. And so we can, round it to like 2 places. We could obviously like run, write code that rounds a number and then displays it to us, but why would we, right? Python has all this stuff built in. It's nice and easy for us, so we can use a lot of the built-in stuff instead, which is usually nice. For today and for a lot of this data analysis stuff, we're really going to be using a lot of built-in functionality from Python or Pandas, just because it's the quickest and most efficient way to get a lot of these tasks done. For data processing, I'm sure you can always find interesting, new, never before seen bespoke tasks, but more frequently, you're not doing something no one else has done before, right? So a lot of that logic already exists somewhere. It's easy to reuse it and much quicker to reuse it. So we've dealt with integers and floats real briefly, right? The last type of Python data type is going to be this. This is what we call a string. String is defined with a quote before, quote after it, right? It defines just like arbitrary text, right? This is my name. You can say literally anything and involve pretty much any character that you can think of that's text-based. Again, most data out there really consists of integers, floats, and strings. Especially if you're not programming specifically, right? A lot of it consists of that stuff, sometimes weird, complicated strings, but usually a mix of these things, right? Numbers and text. And that's going to kind of be our bread and butter here. One of the last sort of Python functionalities we're going to look at really quickly, again, for more of the Python stuff, right? I have a workshop on Monday that goes more into that. For today, it's kind of a need to know basis type thing, so that we can use similar features a little bit later. Python, we also have what we would call a function, and the purpose of a function is like we saw with the built-in round function, right? To make code we can reuse later by name without having to type it out more than once, because one of the most important parts of writing code is essentially being lazy and not rewriting things multiple times. In Python, to define a new function, we use the def statement, def, and then we give it a name. So I can say def example function. If we want to give it any inputs, right? Like round consumes 2 inputs here, right? We have to give them 2 placeholder or whatever number of placeholder names in these parentheses. I'll just say input here for now to give us like a nice, a nice literal example. If you notice, right, if I commit a Python faux pas, we get a nice error trace back here, which is just Python's error message, right? It tells me the place where this happened, the line, and it tells me what kind of error. This was a syntax error because I forgot to give my function anything to do, which is bad. All right, Python mandates that after a colon and a line break in a function, you have something there. So for now, I'm just going to use the return keyword. This is literally a function that takes something in and gives it back to you, which isn't like super helpful for us, but it's an example of the structure. All right. So for example, if I call our function, and to call is what we usually, use as a term in programming for like make function happen. You'll sometimes hear the word invoke, which is a little bit older and in the modern parlance sounds a little bit fantasy-ish and antiquated and kind of weird, but like some people use it still. Invoking and calling a function are the same thing. So we can say example function 9 and we get back 9, right? It comes in, it does nothing, we return it, right? The return keyword kind of gives you back something. We could always make, more give it a damn that doesn't conflict, a more fancy name for some reason. Function that takes in 2 things and like returns a plus, B. Someone else hit the waiting room and it deselected. I told you what happened, folks. And now we kind of have access to like function that will take 2 numbers and return their sum, which is obviously like more useful than this. This doesn't do anything. So if we call example function 1, again, the notebook has nice things like autocomplete for us. So we have a nice reasonable experience, more than we would have had before. Right, for example, 4 and 7, I should get back 11 and I do, right? So we can make like reusable snippets of logic to help us do nice, cool things. Cool. The last built-in feature of Python and really just programming feature in general that we're going to look at, sorry to those I know programming language folks, although if you're one of the ones that only knew C++, yes, you can reassign a variable in Python and it doesn't like complain at you or anything. It's cool with it. As an FYI, I've had students who come from other backgrounds that are shocked by that. I think it's irresponsible. So you guys can think what you do. All right, but it is true if you didn't catch that. The last thing we're going to look at real quick is what we call iteration, which is simply the ability for us to make a bit of code execute some number of times, right? Instead of having to, for example, write this like 8 times manually, you can use iteration to make a snippet of code. One snippet of code that you write happens some other arbitrary number of times. For example, I can use what we call for loop for I in range 6. We can do something like this. And I can take the print function, which takes its input and shows it to you, and run it 11 times with the numbers from 15 up until but not including 26, right? So this line of code happened 11 times, once for each number from 15 to 25. All right. Technically, the code inside our loop, again, it reads kind of like English, right? So for placeholder name of each thing in this range, right? So for each number in range 15 to 26, we'll run this. This can be really useful for like really long, not really long, but repetitive tasks. We're really going to see this in a data analysis sense, from having to apply some sort of transformation to our data, right? Like row by row or column by column, or something that we have to do more than once, but like I don't want to have to, hit shift return on my keyboard like once for each column of my data. That would make no sense, right? So iteration takes, a lot of different forms, I guess, but it ends up being really useful no matter what. All right. And it again shows up kind of behind the scene a lot in pandas, because that's sort of the whole point for data processing. So at this point, I'm going to try to jump to the data analysis libraries. And again, the way I'm going to try to go through most of today is going to basically be, right, sort of tutorial style. I, in all of my years on the internet, right, which is many of them, have found some data off the internet that is, suitably kind of crappy, like most data, right? I'm sure we're all, or mostly here, because we deal with data in some point, either at work or in our lives doing something, and it's not perfect, right? Has anyone here ever gotten perfect data every time? You can say it in the chat if you have. Realistically, the answer is no, right? I'm sure you've all seen articles and headlines about like data science is like the sexiest thing now for employment, right? Which is true. I'm not saying it's not, or, it's like unappetizing. My point here is this, right? Probably, there was a statistic that I forget off the top of my head, I apologize. Probably like 80% of data related tasks end up being cleaning up data so that it can be prepared to be used, right? Most of that data pipeline is like taking bits of data from places or data you've been given, realizing it doesn't work for whatever reason, right? The person that prepared the CSV wasn't paying attention. They copy pasted something weirdly, also it's all in one cell, like all these weird issues, and then fixing them. Because once you have perfect data, you can do almost whatever you want with it, statistically or otherwise, right? And that's kind of institutional thing, usually, what you're doing with it. You can make figures, right? Charts using suites or simple graphs, whatever. But a lot of it goes into that. So what we're going to go through today is the process of reading a CSV that I have acquired from the internet that is suitably kind of messed up, and then trying to fix as much of the data stuff that we can, manipulate it so that we can get some much more useful, better output towards the end of the workshop. All right, so we're just going to go step by step, look at a bunch of basic functions we can use, to perform basic data related tasks, right? Some math, some manipulation of our data, some changing our data types, right? How we can apply some transformation to all of our data set, right? Stuff like that. If you're curious, every time you open up a Google Colab notebook, congrats, ignore these year.csvs, this is my data. Every time you open up a Colab notebook, there's this sample data folder as well that contains a bunch of sample data sets that are like the data sets that are frequently used in like data science and machine learning tutorials. Some California housing CSV that I'm sure is like, yes, this is like 300 kilobytes. This is a megabyte and change. This is like a lot of data. There's an MNIST test and train data sets. So these are handwriting character data sets. I think they're images off the top of my head, or at least links to images, right? So you can always play around with these, but I have all these CSVs that I have painstakingly loaded and labeled instead. We're going to be using one of them to start out with. All right, so I personally am one of those in my teaching career, right? There are a few things I try not to do, right? One is use the phrase "hello world." I just don't do it. It's just overused in programming, and it's kind of cliche, right? So I refuse to do that. And the other one is that I try not to use the same types of data sets that people generally either see at work or see in other tutorials, right? So I'm not going to be using like stock or crypto prices or financial data sets or any of the big data sets. Like there's a movie data set that's huge on the internet and stuff like that. Try to use something a little bit fun, a little bit interesting, a little bit random, right? So if it's not your cup of tea, that's fine, right? I'm going to be using sports data. I'm just going to be using American football data. If it's not your cup of tea or you don't really care about sports, it's fine, right? Strings are strings, numbers are numbers. It's just the data set that I found that works best for this workshop. But hopefully at least using data that's not like as jobby is a little more fun for this, evening after work. To that end, I'm going to be using NFL, right? National Football League data from the year I was born, 1992, because like honestly, nothing of too much relevance happened before then, up until 2018, right? Which is some amount of data. We'll see exactly how much it is. And I'm not going to be using literally all of these CSVs today. I'll try to include them all for you just in case you want it. I downloaded all of it from sportsreference.com. It's free. It's easy to use. They're just CSVs you can download. But I'm going to be using this football complete. It's an aggregate of all of the data from all of these 20 something years, 26 or 27, I think. I'm almost 30, so like it's something around there, minus the last few years. So without further ado, I'm going to read a CSV into some sort of built-in pandas object, and we're going to see what we can do with it. All right, so first going to use the import keyword in Python. Let's do a few things. And as you can see, right, these autocompletes are taking these very, very often used imports and auto-completing them for me. And I'll explain them in a second once I spell everything correct. Cool. Then I run this. So in Python, the import keyword is what we use to essentially import or gain access to all of the code in some external library. Here it's pandas, Numpy, and matplotlib. We're certainly going to use pandas. If we have a little bit of time, I usually try to use matplotlib just because it's a quick, easy charting library. It spits you out like PNG images, which as you are, playing around with this stuff, it's nice to have a graphing library so you can create some sort of visual output, right? Because ultimately no one cares about the code so much as they care about the output of the code and the data. Well, that 80% of time is spent cleaning data, right? Like the thing people actually care about is the stuff after that, obviously. If we don't get to it officially on the call, I will definitely make sure this notebook has some sample code for it by the time it hits your inbox. I promise you that. All right. So once I've imported these, I have access to all of their functionality if I want it. I can either get it from the library by name, or I can use a short alias. Even though these names aren't long for pandas and numpy, it is canonical and it's just the way it's done every time to abbreviate them as PD, NP, and PLT. And every time you see anything related to data processing in Python with these libraries, these 3 lines will show up there. I guarantee it. But again, I haven't done anything, right? I just have the ability to use them. Google Colab installs these, so you like don't have to do anything to install them. You have access to them immediately, which is great. You also, if you care, have access to a bunch of machine learning libraries like TensorFlow that we aren't going to use, but you have it for free. So if anyone wants to like mess around with that this week or something, like go wild. Feel free to. It's cool. So once I have these imported, I can create what we call a data frame. And this is one of the first places that we will be able to, start using the functionality of pandas, right? So as you can see, right, the notebook does a lot of helping you, which is why I kind of encourage this to be both very tutorial-y as we walk through this, but also for you guys, just like try to get your hands dirty and try to write some code and try to make stuff happen. Notebook's very forgiving, right? Autocomplete gives me a list of all of the methods I could try to use from pandas, right? There's a ton of different read methods. Basically, all of these will just try to read some data type. And by data type, I don't mean built-in Python data type. I mean like type of data, right? Some file format into your program. For the guy that mentioned SQL in the chat, there's a read SQL or a query or table that actually can make a SQL request, right, to get data from a database and read it into some sort of, in-memory Python object, which can be nice if you have a real database or interact with that. If not, there's all kinds of HTML, JSON, or things that people who don't use coding have heard of. There's a read clipboard, which I think goes to your clipboard, something you've copied and tries to do that. I haven't used it, but it might be relevant. There's Excel, right, which will read an Excel file, try to read that into pandas, right? If you work in Excel and not actually CSVs, I'm using an actual CSV, the simple non-Excel thing you can export from Excel too. So I'm going to use read CSV and then give it a file name. I'm going to call that football_complete.csv, which is this file right here. Without looking at it, so I know it's in it, I can just run this line, and in a relatively quick amount of time, it would be quicker on my own machine, but again, this is happening in the cloud. I have this data frame, right, df. It is standard practice to call it df. I'm not just like making this name up. It's the canonical name for the data frame, which is the fancy word for what pandas uses to represent two-dimensional data. By two-dimensional data, right, again, think spreadsheets, right, columns and rows, or SQL tables, or any table or chart you've ever drawn, right? It's got columns, which have names, which sort of are the kinds of data or attributes you have, and then rows, which are the entries, right? Which is great, right? But obviously I can't see this. Normally, if it's your own data, you like kind of have a gist of what it looks like. But to make sure this read in correctly, I'm going to use a data frame method called head. Actually, I'm going to not use that. I'm going to first use, well, first just print our data frame, right? Type df, see what pops out. Took a second. But we get this, right? This is data. This is technically, if you care about football, This is the data of every offensive player who has either caught a pass or attempted a rush between 1992 and 2018. All right, should I have added data at some point since I started doing this workshop? Probably, but I haven't gotten to it yet. If you notice, though, it looks like it doesn't make too much sense, which is fair and true. The point here being, right, the NFL is a relatively large league, right? There's 32 teams. Each team's get a lot of players, right? A lot of players catch passes and or attempt a rushing play throughout each season, right, of 16 games, now 17. Which means that our data is not an insignificant length, right? This isn't like 6 dudes. This is technically 8,310 different players' seasons. All right, yes, it came from that many CSVs. So each player has as many entries as years they played, which is fine. But that means it's 8,310 rows. And I tried to open this up in Excel once, or not Excel, technically it was Pages because I have a Mac and haven't paid for the license, but it didn't go so hot. Right, 8,310 rows is a lot for like something with a GUI, but for something that uses code, it's fine, right? We get an ellipsis, but ultimately this will display to us the first 5 rows and the last 5 rows. So we can go from Edgerrin James to Mike Williams, right, which is sorted in some order that I am off the top of my head not sure of. Actually, it appears to be yards, judging by this column. Maybe not. No, not quite. But so we're part way there, but not obviously all the way there. So we have our data, but also this is a lot to look at. So let's not look at it, right? Let's look at only a few rows, right? So the data frame has this method. And by method, I mean thing that looks like a function, but is not a function. Methods are callable, but they belong to a specific object. So this is a data frame method called head that will act on this data frame and to give us a specified number of rows. So let's just say 2, right? I'm gonna make the assumption that if 2 rows look like they read in correctly, all 8,000 and change of them have read into our program correctly, and it looks like they have, right? We technically have 20-something columns, I think. I can't really tell, honestly, which should be plenty for our analysis, right? It looks like 90% of them are numbers. There's this one, which if you think about it, definitely isn't a number because of percent signs. This is probably something we need to change to be a number. And the name looks a little bit weird. We'll see a little bit later. There's some other things that are messed up consistency-wise in some of the other columns. But for now, we're going to start with this data, transform it, and then see if we can at least get some nice, more usable output. Because right now, this is honestly going to be kind of hard to use for a lot of tasks for me. All right. Again, if as we go, you have any questions about this or anything tangentially related to it, like feel free to throw it in the chat. I'm still looking at the chat. I'll get to what I can, but seeing as there are currently 45 of you, I guess, because I'm 46. If you have anything to ask, feel free to throw it in there, right? There are very few questions that I won't say stupid questions. I'll say questions that I won't answer. Irrelevant ones I'm less likely to answer, given that it's already 6:50, but we'll see. All right. Feel free to throw it in there. I can at least address it quickly, right? Just let me know if you have any questions about like, is this useful? Can you do this? Can you do this? Is it easy to use? Have you heard of it? Like whatever, right? I've heard it before, I'm sure. So feel free to fire away. All right. It's been oddly quiet so far. Cool. Right, once you've seen our data, we've read it up into memory, we can start trying to analyze it, right? Like, again, we already saw the, where can we find CAVs? So if by that you mean, where can we find CSVs, like the files? You create them. If you have an Excel file, you can export to CSV. A lot of places on the internet give you CSVs. CSV is a file extension, right? .csv. Stands for comma separated values. It's basically the really, really basic version of a spreadsheet, like Excel. It's a table where new lines are. Oh, the one I'm using, I will you do it with LibreOffice. Pretty much any spreadsheet software, meaning the ones I've used, I think LibreOffice, Excel, and Pages, the Mac one, all let you export various spreadsheet files to CSV. I believe Google Sheets does as well. All right, so you can at least get one of the views or pages or whatever they call them, right? Sheets to CSV, and then you should be able to take it and just do whatever you want with it. All right, but the internet's also littered with CSVs. So if you want to just play with something, just like search for CSV data set 4 and then like thing you're interested in, and there should be one there. I promise. Good questions. See, can I do this? Yes, it's a good question to ask. The ones I'm using, again, I will send them out to you guys afterwards as either like a zip file or via Google Drive. All right, so you will have access to all of these if you would like. Otherwise, the data is from sports-reference.com. They got a bunch of sports if you like sports, but they also have easy CSVs, which is why I have them. Cool. So Python has a built-in length function, right? So if you get your data and you have no idea how much data you actually are working with, for example, like one of these other files and one of these other sample datas where I could just try to figure out how much data is there. We can use a length function, right? LEN, which will tell us how many rows we have, right? 8,310. So this is number of entries, right? It works for pretty much any collection in Python, list, dictionary, whatever. We can kind of look through it and get our nice, length of our data, because again, we can't look at it and count, right? So we need some other ways of getting like a quick synopsis. There is also a built-in describe method of our data frame, which is even better because it means I can do a lot of normal statistics upon every row of my data real fast, which is great. So this is going to give me a readout of basic statistics for all of my columns, right? How many values are there? What the average is, what standard deviation is, what the minimum is, right? Quartiles and the max, which honestly, like it's one method, it's one table, but you can honestly get a decent amount of mileage out of this, especially with a huge data set, right? For example, I know that age goes from 20 to 44, which is shockingly old. Right, with the average age here being like 27-ish, right? So obviously it skews much younger than 44 on average. Right, standard deviation being roughly 3.5, right? So most people are within reasonable few years of 27, right? So roughly doing quick math in my head, roughly like 23 to 31 or something ish. All right. You can look at it for all these other columns. Obviously, they have kind of annoying names from Sports Reference, right? Games started at 10 yards. I know what most of these are because I have, domain specific knowledge, which you probably have for any data you use, but you get the same stuff for everything, right? And by a quick note, it looks like my data is not like completely corrupted, right? Like games shouldn't be more than 16 if it didn't start this year, which is true. So most of this looks, good enough, right? But you can again get a lot of mileage out of a lot of these basic descriptive methods like describe. There are a few issues though that this is bringing to mind. If you scroll over, you'll notice that like all data, right, a bunch of columns randomly don't have the same number of values. So we have rows with just completely missing values, which is kind of a shame, right? So this leads to one of our first important data related tasks of the evening, forward filling our data. And forward filling our data is essentially just how we're going to find, or filling in our data in general. Forward filling is way to do it is just figuring out a way we can replace missing values with something that won't mess up our analysis. We don't really have a good analysis that we're going to be doing, so I'm going to make it up a little bit, but we need to think of some quick way to add in what looks like 2,500 values to a bunch of columns or so. All right, so for our purpose, there's a few things we can use. There's one thing built into Numpy. The other library that is not pandas that I imported, right? Numpy, which is, unlike pandas, it's not specifically a 1 and 2 dimensional data analysis library. Pandas is that. Numpy is a scientific and mathematical computing library. It's got a lot of linear algebra and like helpful data related tasks in it. But it has this thing called NaN. Oops, we have A at the end. And it is essentially a value. I use Python's built-in type function. We see that it's actually considered a float, even though it's not a number, and it literally stands for not a number. It's usually used actually to fill in data, right? It's used for basically missing values. It's not a number, so it won't skew value calculations, but it will exist, which is its point. So that's one option for now, because most of the missing columns are numeric, and almost all of these are actually counting data, right? It's totals of things or averages of things. I am going to say that anywhere it exists, it doesn't exist. So I'm just going to fill in a 0. All right. Whoops. So I'm going to use this built-in function called fill_na, which it will fill in values using some specified method. There's a lot of arguments you can give it. For now, I'm just going to give it a value, right? So a method is a complicated way. This is like, if you want to use some functionality, right? Fill it in with values based on this criteria. I'm just going to give it a static value of 0, right? So anywhere with our data is missing, I'm just going to give us a 0. Quick note, right? I overrode our old data frame with this new manipulated version of our data frame, which sounds weird, but the way pandas works, because you're dealing with large amounts of data for your own sanity, it will not manipulate your data without you expressly telling it to. All right. So for whatever reason, if you go into try to mess around with this, right, and run this just on its own, this will technically create a copy of your data frame, right, of your data with this transformation applied to it, but it won't change the original. So df hasn't changed. It's just kind of printing me out like a test, which is nice, right? Because you don't want to accidentally overwrite your data and mess up all the careful work you have done previous to this cell, right? You can always rerun all the cells and like it's all in memory. It will fix itself, but it's much easier. Once you're ready, once you've transformed your data and you're ready to officially overwrite it in memory, right? Make df updated, either reassign it so that we may now make df equal to the output of this, or there's another syntax for pretty much all data frame methods that change the data frame, where you can use this in place argument. This in place argument is in place equals, and then after that we give it either true or false. And in place equals true, we'll simply say, all right, overwrite, right? Perform this action and overwrite the data frame. All right, so perform our data transformation and overwrite the data. Right. All right, this is 2 ways to accomplish the same thing. This is the like functional Python way to do it if you're more comfortable with Python or programming, right? It's just another function argument. If you're not, this will again just overwrite df with the output of this method call. All right, either way, we get to a point where if I run this again, all of our columns have the same count, which brings me to something important, right? Again, I mentioned at the beginning that we can put a lot of code in our cells and run it in isolation, but also technically our notebook is saving, right, preserving in memory the output of each cell, right, whatever the result is after each one, which means we can run them out of order, right? If you notice, I ran describe before, but now that I ran a lower cell and df changed, the df this points to also changed. So now df is the most updated version of our data frame. This isn't running vertically. This technically runs cell by cell, which is why you get a nice input count in brackets before each of these lines. So this is the 34th cell. I can't highlight mouse over it, excuse me, play button. This is the 34th cell run that I have, right? So it will use the state of all the cells before it, right? 35, 31, 30, whatever. All right. This can be confusing, and it's always good to run your cells in like a vertical order so that it makes sense to you after like 5 minutes of not looking at them. But also just know that technically, so I'm going to move this down now, use the arrows. But technically, you can run them in any order and it will work out mostly. All right, it will just be a lot harder for you mentally to process like the order you ran everything and what the current state of your notebook is. All right. If I didn't want to use the count, there's also built-in functionality to manually check for missing data. There's a df method called isNA, which is just used to detect missing values. The issue is that by default, it returns us an entire data frame of Boolean true false values, which is not useful in any way, right? Like you could scan 8,310 rows and 28 columns to figure out like, is anything here useful? Is anything here true? But that's going to take a lot of effort. So we can chain the any method to it, which will simply take a collection of values and tell us if any of them is true. And now I just get a readout that, you know, if does any column have a missing value, and we get all falses, which is good, right? It means that we in fact have no missing values, right? We're mostly good to go, right? So I've checked one box off. I have now successfully got rid of all the missing values in our data frame. Now I'm going to check a little bit, right? Perform a quick check of one of our functions. All right, not one of our functions. I was reading my notes, apologies. One of our columns. So if you want to look at a column specifically, you can either treat it as an attribute in Python. So if you want to look at our position column, you can use a dot. So df dot column name works here, right? We get all the values as a long series, which is honestly not very helpful for us. If anyone's thinking, right, you will sometimes get column headings and data that like have spaces and stuff in them. Space is obviously not a valid bit of a Python name, so that you can't use the dot or the attribute syntax with a column that has a space in it, like a lot of data does. So instead, we can use the bracket syntax here to access a column. It does the same thing, right? But this way we can have like spaces in it or something if we wanted. And we can, see the output of the column and see what's up with it. All right. So I'm going to look at this column, but obviously there's like way too much going on here, right? This is, 8,310 values. So instead, I can use the unique method, and I will simply just look at an array of all of the possible values we have for position. And if we look carefully, you may or may not know anything about football looking at this data, but this might, hopefully for anyone, right, be a little bit of a red flag, just because we have all these, things with slashes, things in different case, trying to find two that are the same. There we go. There's a big K here. There's a little K here. These are definitely the same position, right? It's both kickers. Just all kinds of weird issues, right, with the casing and the representation of our data here, right? This is like par for the course for most data, obviously, but so we might want to think of a way we can clean this up. And I'm not going to think of a really long, comprehensive way we can do that, because we don't really have time for that, honestly. And there's so many positions and, permutations of this that we're not going to look at it right now. But, for most data, you can always, right, that's your side of things, right? What should I do? What domain specific knowledge do I have where I can say, actually, right, because these precipitation totals are all within a certain magnitude, we should actually do this to transform them, right? Like whatever it is that you do, right? That's the logic side of thing that Python can't handle. You just tell it what to do once you know what to do. But I am going to take a subset of this, right? So I'm going to pick a position. I'm going to take the first one, I guess, running back, right? RB. And I'm going to quickly look at how we can at least take, some of these guys and make this data a little easier, right? So off the top of my head, we got capital RB, we got lowercase rb. We got a lot of slashes. We're not going to deal with slashes right now, because that would involve coming up with rules, and we don't need to come up with enough bespoke and or faked football rule set knowledge for this to work. I don't see any others, but there may be like a capital R lowercase b or something in here that I'm not seeing. Right, so we're going to try to standardize at least one position's name. All right, so I'm going to make a list, right, which is a Python data structure that is simply a collection of things. Yes, the person asking in the chat, POS is the name of the column. It's not meant to be like vulgar or anything, right? It's just position. It's short for position. It is not in this little readout. There we go. So it's not showing up as far as I can see. Oh, this is only the numeric columns, right? That's fair. It should be right here, right? Yes, I don't have a list of the columns. Again, that actually brings up a pretty good point, right? There is a certain implicit knowledge of your data when you do something like this with code, because you're not necessarily looking at it, right? Like we showed the head function earlier. A lot of these different methods show us, a lot of different things about the data as we go through it, right? Or like little snapshots occasionally, but you're not staring at it the whole time. So there's a certain amount of data you need to know, or at least you need to know enough of like the column names or what the values should be to be able to use it. Good question though. If I didn't say it enough or clearly enough, it is a column, right? So this is accessing a column. We could do it with any of the columns, right? And get all the unique values. Cool. Now I'm going to make a list of, a bunch of strings. These are the acceptable, not acceptable, these are what I expect, right, for running backs. I will just use literally every permutation of R and B, even though I don't think the middle two are in there, just so I can be comprehensive, right? So if we find these, we're going to assume it's a running back. We're going to try to replace it with probably the capital one, right? I like the all caps make sense. It's an abbreviation anyway. Before I do that, I'm going to comment this out real quick. Right, a comment is just code that doesn't run its annotation. I'm going to quickly, run one thing. So there's a few ways we can try to access our data from our data frame. There's this method called iLoc. ILOC, which is index location, which essentially lets me give it a numerical index. So that's basically row number, right? So row number 2, and it lets me look at it, right? So ILOC2 is going to give me Emmett Smith, who's like row 2 apparently, and it will give me that row. For this data, I'm going to make a general case that this is useless, right? Because like out of 8,310 players who have played football over 26 years, like I don't know how to access like who player 2652 is, right? I can't get you the right player season that you ask for on demand, right? So this is like not really helpful. There is alternatively by numeric position. Row 2, cool. There's another way we can do it instead though, and this is the Loc method. So df.loc. Notice that this syntax, if you've used code before or just noticed the little inconsistency here, this isn't parentheses like a method call. This is brackets for both of these methods. It's just a syntactical thing in pandas. It took me a little getting used to when I learned it. It might take a little getting used to as well. It's just the way it is. All right. The Loc method is actually helpful because you can here put a condition in here and it will give you that bit of data, right? So if you want data where this is, you know, this value is greater than a certain number or a certain threshold or something, right? You could say, if you've like, for example, a guy in the chat who's used SQL before, right? It's the same example as you were like where clauses and stuff, right? Give me this subset of our data somehow. You know, if you've ever had to use data before, I'm sure you've needed to do like, you know, give me these rows, you know, these specific rows, right? All the ones where time elapsed is less than 1 week, right? All that stuff. You can get your queries so that instead of 8,310 rows, we can deal with all the running backs, right? Or something like that. For example, we could do something simple like df. I'll explain the syntax as we go. I know this is for some people like never seen Python before. That's fine. Right. I'll explain some of the syntax in a second. It's just harder to do the typing and talking at the same time. df started greater than 12. Sure. Right. Let's get players who started. GS is game started. It's a column. It's a numeric column. It's an integer. It's going to be between 1 or 0 and 16. So I want all the players who started, right, were good enough to be like the guy for at least 12 games, right? These are like starters, right? Good players enough. Giving 4 games wiggle room for injury or like whatever. It's an arbitrary threshold. This will get me all those players. If we look, there are in fact only 1,960 of those players, which isn't surprising, right? Our data includes everyone who rushed or caught a pass, which includes a lot of random people or accidental people or something. So we have filtered our data now to about 2,000 rows already, right? 2,000 players, which is cool. Again, you can do this with any data, right? Again, there's, as I keep mentioning, there's always a little institutional knowledge you need to have, right? For this to work, for these queries to work, right? For your analysis to do anything. So I am going to not only do this now, but I'm going to add a second condition. So I'm going to put them in parentheses to group them for our eyes. So a little easier. Python lets you group conditions or expressions just like math does with parentheses, right? If you remember PEMDAS and how parentheses group bits of mathematical expressions, just to keep them separate and easy to read. I'm going to do that here. So here we're going to say df position is in position list. So I'm going to unpack this again, but ultimately this is just a query. It's a little more advanced than some might be, but We want to also give you guys examples of like what you could do, not just all the basics. So here we can use an ampersand to basically make an and clause, right? So if these two are both true, this and this, so this is going to locate all of the rows where this is true, right? So our entry in the position column is a method that does the exact thing you might expect it to, right? It checks if that value exists in some collection of values. So all this is doing is saying, all right, does the entry in the position column exist in this list of values, right? So all of the rows for which the position, the row in the POS column, is going to be either this, 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 or this. And the entry in this column is greater than 12. All right. We get back 471 rows. And off the top of my head, these are all greater than 12, right? We get a lot of 16s, we get some 13s too. And these all say capital R, capital B. If you want to play with it, right, you can, part of, you know, data processing, data analysis is always like playing around with the data a little bit. We can kind of see, you know, how many players we get here first. All right, 1709. But like these three guys played one game and may or may not actually exist in meaningful capacity in our data, right? So it may be worth, you know, kind of seeing like how the data scale changes. So I'm going to take this smaller subset, right? 471 rows. Yes, that's correct. As I mentioned before, we used brackets for the LOC and the ILOC methods. It's a weird syntax. Correct. So almost, so 99.9% of the time, a method will use parentheses. The only ones here we really need to be aware of are loc and iloc, which use the brackets. More like accessing column name and less like a method call. I'm not 100% sure what the actual implementation reason for that is. My guess is that it's either because you're accessing data. In Python, this is traditionally a data accessing syntax, right, using brackets. So my guess is that either to make it look more like that, because what we're doing, or for some other implementation reason that like it's not technically a method or something, it is brackets here instead. Again, it might trip you up a tiny bit at first, but once you try to get the hang of it, you can, you know, use this, just try to put in different queries and comparison operators and stuff and see what happens with your data. And you might be, you know, you'll get the hang of it once you've typed a little bit and run a bunch of, you know, queries on your data and gotten stuff back. All right, but good catch. It is true. We do use brackets here. Cool. Otherwise, now that we have these, this subset of our data, we can do what we want with it, right? I'm going to actually now reassign this to a new, you know, some new name. I'm going to call it RB_list, so I know what it is in the future. Rerun this, and now instead of printing me an output, we have this new accessible variable of like, here's our running backs. So I can, you know, look at their data, analyze it, do whatever I want, right? Because frequently you'll need to grab like a subset of data, analyze it somehow, or clean it up, or use it specifically as opposed to like the whole bit of data. All right. Additionally, if we want, we can start taking, you know, take our data frame. So use the head method again once, right? Look at 2 rows, just remember what it looks like. There we go. We can also start creating our own calculations, right? Our own columns to the data if we really want to. So I'm going to create a new column, right? Oops. I mean, I'm going to give it a name, right? I'm going to call it T_PTS, right? Total points. This is one of the only calculations I could think of that was really easy and quick. that I can do on our data, right? But you can always, for most data, you can think of, column plus other column, some other math, right, to get a new output for each row. So for each of our columns here, I am going to add up what would be, for fantasy football, I guess, would be the total points for that player that season, just because it's like a quick, really easy mathematical calculation that isn't like fancy statistics or like advanced statistics or something that would be harder to express for people who've obviously, not known too much Python. Because some people here haven't. This is really just adding up 3 columns and multiplying them by like a number, right? So it's going to be df this column, so RRTD. This is touchdown scored, times 6, plus another column, df capital YDS yards times 0.1 plus df receptions times 1, but like obviously times 1 is the same thing, so I'm not going to change it. We've seen this syntax, right? We're accessing a column. So what this is basically doing is this new column, right? Total points, which doesn't exist. So if you say df column that doesn't exist, it will create it, right? T underscore PTS. We can add these 3 numbers together, right? So the value in this column times 6 plus the value in this column times 0.1 plus this. I'm grouping these expressions together with no space around the operators, simply so we can see the 3 parts of this more easily. It may be easier to read if you add a space depending on your own preference, right? So you can always do this. And it might look or be easier for you. Again, I'm doing it to see the 3 parts more clearly. If I rerun this, we suddenly just have a nice new column in our data at the end, right? Total points, right? So a little bit of float now, but ultimately the math worked. We have our new column. If this is what we're trying to use, we can be good to go and start using it nicely. All right. Really quickly, I'm just going to check, right? So I'm going to just make sure that this column, again, right, we have 2 syntaxes. We can use the dot, or you can use the brackets. They fulfill the same purpose. The only difference is that, again, with the dot, you can't use spaces, which is why there's an underscore here, right? But I'm just making sure there are, in fact, 8,310 values, which there are, so which means I'm, didn't mess up. I'm good to go on a little bit. There are also really handy functions you can use built-in to pandas. So there's, for example, there's a lot of data analysis, data manipulation tasks that like everyone needs to do sometimes. For example, things like a cumulative sum, right? Like a running total. There is a function for that. I'm just going to quickly, completely arbitrarily demonstrate that. Equals df dot. So touch, right? This is touches. This is number of times that a player interacted with the ball, right? So things they did. It's a column in our data set. What matters is an integer, right? Dot cumulative sum. This is in fact a method of our column. It's just a running total, right? So think first value plus second value, that total plus the third value, right? So at the end, we'll have the total, right? The sum of all of the things, all the numbers in that column. But if I run this, I can jump back to our df.head and we get this, right? Which starts at 431 here, right? We add that plus the next player until the last row where we probably get, oops. Actually, so I'll use this method tail, which is the opposite of head. It gives you the last row or number of rows of our data set where we end up with 520,316 total events of players interacting with the ball over those 27 years. Which isn't necessarily a useful number. Again, it's just like this feature exists. It may be helpful to use for some people. All right. That's X rows or whatever number of rows of data. So the last thing we're going to do, right, one of the last things we're going to do to try to interact with our data, right, is we're going to try to clean up this name field, which like intuitively we kind of probably know what we're trying to do. But at the same time, we're going to have to do some transformation for every single row in our data. So because it's getting a little, 7:30 here on the East Coast, I don't know where everyone else is. Does anyone quickly see a problem with this data? And does anyone have an idea what we might need to do to solve it? Will someone give a different result from, I don't think so. So some df. Yeah, so they give the same, there we go. So some function in Python will give us the same number. The only difference is it's not a column method. These will both get a sum, right? A running total or a sum. So they won't give you the different output necessarily. But off the top of my head, I'm not sure how this would interact if you did this, right? So this cumulative sum, technically, the first row is going to be its own value. It will gradually increase throughout your data frame. If you did like df total touches equals sum df.touch, right, like this, every single column would have a value of 520,316. So it's like a use case thing. I kind of made something up, so it doesn't really matter. But yeah, this will give us a total from top to bottom, like a running tabulation. This will give everything the same value. Does that make sense? Hopefully. Cool. Good question. They have the same logical end, but the what goes on is different. Cool. Which is also why it's like a column method. Cool. So real quickly in the chat, next like 40 seconds or so, does anyone think they see a way we might be able to take this name column and transform it so that we get real names, first, space, last, and that's it? You want to type something in the chat while I take a quick drink because I've been talking for an hour and a half. What do we think? Thoughts? What might these names need? What's one thing we might be able to do to this column, which doesn't have a name yet, to these values so that they say a name? Just the first, last, right? So I want this to say Mike Williams. Any ideas? Yeah, so someone's talking about that forward backslash. So we probably need to, right, trim whatever comes before the backslash. Anything else? Anyone else? All right, this is actually a bad one right here. Let's look at Edrian James. What else? So trim at the backslash. What else might we need to do? Thoughts? So there's also, right, some special characters here. We're also going to need to remove those. We're going to treat it as a two-step process. To do so, I'm going to make two quick functions real quick. Actually, I'm just going to make one function for now. So def. Call it name underscore clean. This will be our function that cleans up a player's name to get us back their real name, right? So take a name as an argument, and we're going to take in that name. Let's see. Name dot split. And I'll mention what these Python methods are in a second. Oops. There's backslash. Spell strip right. Asterisk plus sign. If you don't need that name equals, I can just return. So in Python, it's common to see like a bunch of methods chained together after each other like this. We could write this as 2 lines instead. So these 2 lines are the same as doing it all in one shot. Python, it's usually considered proper to chain stuff together like this, so it takes up less space and is a little bit more succinct. All right. These are largely the same. What we're basically doing, as someone at least mentioned in the chat earlier, one, we're using the split function. We're taking, sort of splitting on this indicator, right? So this will actually give us back a list of 2 values, the thing to the left and the thing to the right. Index 0 gives us the thing to the left. So this is a long form way of saying, get me everything to the left of the backslash in the name. And this strip method is then taking that result and just saying, and get rid of these characters from either the beginning or end of the string, right? Strip is a helpful function that just gets rid of whatever characters from the ends of the string, ignores the middle, which is important. You know, there may be things in the middle of the string we don't care about, but all these like footnotey bits all exist at the end here anyway, right? Once you've cut it here, we end up with this on the end of the string. Just to make sure this works, I'm gonna call name clean on the name for Edger and James, which if you care, they look weird, but this is footnotes, and this is the URL snippet on sportsreference.com for the player. Let me get back. Name.split, index 0.strip. Oh, I didn't rewrite this after adding the index. There we go. Cool. Again, sometimes you'll miss things and not actually run it because it's a notebook. Happens. Right, and we get back what looks like the real name we want. So I'm going to say that for now we've tested this and it works. Cool. Once we have that, we can try to apply it to our whole data frame. And obviously this is like, obviously for this workshop, this is one of the more important, a little more complicated, but more important things we can do, right? You can always look and do it, mess around with it. But a lot of the time you have data. You need to run some transformation over every column, every value in a column, right? Something like that. Built in, so real quick, this is the name of the column. It didn't have a name coming in, so pandas just makes these up, right? We got unnamed 0 and unnamed 1. We can take this and we can just say, all right, so this column is just now going to equal column name. Let me try to run this real quick and make sure it, there we go. Let me run this. Cool. So the apply method essentially takes in a function. Here it's our name clean function, and it will apply that function to every value and then use the output in its place. All right, so we'll get a list of all the outputs of that. So essentially we'll get a list of, you know, all the values in unnamed 1, but run through this function, right? Or player name, run through this function. So we should get back a list of clean names. If I run this, see Mike Williams' name is clean, which is nice. If I run this again, see these 2 names are nice. So I'm gonna assume for now that means our data works, right? We've just correctly cleaned this up. We've made this work a little bit smoother, right? Made our data a little more useful. If we want to do the similar thing, right, we could always, actually, I'm not going to do it right now because it's not in my notes. And I don't need to spend a little bit too long making something up on the fly. If you want to practice though, for example, you could always go to like this column, right? Catch percent, which has a percent sign denoting that it is in fact a string, not a float. You could try to make a function that gets rid of the percent sign and then converts it to a number, right? So we can use this as numeric data if we want to, and not as text, which is like kind of garbage for a number, right? I can't do any analysis with this other than look at it, right? So there's all kinds of, I'm sure you guys have seen, right, weird transformations. This column needs to actually be this. So, right, you can do it to, you know, change magnitude of a column, right? This is a decimal, I want it in hundreds, right, of like percentages, like, you know, 0 through 100. Maybe it is 0 through 100, you want it in decimal, right, because it's easier to use, right? There's all sorts of trivial or really complicated, right? This can be as complicated a function as you want. So if you want to perform a really complicated analysis on a column to transform values, you can do that too. It's all up to your own creativity and ability to use Python, obviously. But once you have a little bit of this, you know, technologically under your belts and a place like a notebook to start in, it's pretty easy to look little quick things up off the internet and play around with it, or even, you know, learn a little Python, be it from the intro course I teach on Monday, for example, or like anywhere on the internet. There's just so much intro Python on the internet. I'm sure you'll be able to stumble upon it eventually, if you're interested. Otherwise, to sort of finish this data analysis right now, I'm going to really quickly replace these column names that don't mean anything and are kind of garbage because they're unnamed colon space and then like the number, right? We had 2, so it's 0 and 1. With something more useful. So I'm going to say df dot, let's see. So I'm going to drop a column and so I'm just going to give a drop a column name. Let's see, named colon 0, x equals 1, I think. And it just takes a column name and gets rid of it, right? So we lose unnamed colon 0, which is like an index that was held over and isn't useful to us. The axis is simply if we're dropping a column or a row, right? Axis equals 0, we're dropping a row. Axis equals 1, we're dropping a column. Obviously, I mean, I've never really gotten the dropping a row argument. Like, I'm sure there is a place where you'd want to like get rid of some of your data maybe, but usually rows are like data, so you don't want to touch them as much, but argument is needed. Once you've seen this, we're cool with it. I can add in place equals true again to not just create a copy and show it to me, but to actually overwrite our data frame instead. And manipulate it so that now we should no longer see this unnecessary column. It's gone. Cool. So the last thing I'm going to do then, right, now that we have names, is rather than rename this column, only I'm going to make it our index, and our index is what we can actually use to access, as the bolded reference column for our data, right? This is our semi-unique reference to any of our values. All right, so I'm going to quickly df.set index. There's a built-in method for it, right? Set index is just the name of the column you would like to be the index. And this one I'm just going to throw in place equals true in there because I know it should work. Obviously, Don't throw stuff like this around if you don't want to overwrite your data by accident. I've done it before, it sucks. You have to rerun all your code up to that point, basically, usually to like get your data back. But at this point, hopefully, I should have a new name. And finally, I'm going to rename it. And now I have a little bit of a better name for it. So our data should look nice and clean, at least to a point, right? It says name instead of index, and we have names. At this point, you've probably seen a little bit of a sort of a recap, right? A little bit of a pattern here, right? There's methods associated with the data frame, or methods of the data frame, right? df.drop, we're dropping a column of the data frame. Columns can have methods, right? Set index is a data frame method. Index has its own methods, right? Df column name dot method, right? We saw it like here, right? Column dot apply. That's kind of the way Python's object-oriented syntax works, but it also kind of, once you wrap your head around it, makes using something like pandas relatively easy, right? If I'm trying to apply, right, to do something to a column, odds are that there's a method for it that lives at df column name dot something, right? Method name. I'm trying to do something to my data frame, it's probably df dot method name. If you think you know a method and you're like learning and you're trying to remember it, if you pause, right, do thing dot and then pause, all of or most of the popular possible autocompletes will pop up for you in the notebook. It should help you, right? Which is nice. So there are all kinds of little, learning tools, I guess, built in here if you would like, that can help you. The last method we're going to look at to save our data, I'm going to use 2.2_CSV. Yes, you can save your data as, you can save it to your clipboard, you can save it to CSV, right? Basically all of the different types of stuff we saw before, all the different file types. Use CSV again, right? CSV in, CSV out, it's easier. You could use Excel, you could use whatever you wanted to open it as, I guess. SQL, if you're, if our SQL professional is still with us. And ultimately, just give it a name, right? So I'm going to call it new name .csv. Be nice and literal for y'all, right? And then once that runs, we have it. Obviously, this is a Google Colab, so like this file may or may not actually show up here, or I may have to. Oh, I probably have to refresh it. There it is. It's here, right? It's in Google Colab, so you should probably download it if you want to keep it, because they purge the data in the files every so often, unfortunately, on their servers, which is why I'm going to send most of these to you separately. But you can save it to a CSV or a different file type. Once you're done with your analysis, you have some output or something. All right. Otherwise, that is where we're going to stop for tonight, right? Again, these are really deep, open-ended subjects, especially for people who may or may not know much about Python. So first, I'm going to thank you guys for showing up. But if anyone has any questions, I'll stick around for a little bit anyway, so I can answer those about where you might start, other things. Anything else related to Byte Academy or Python or pandas or data processing stuff, I'll do my best. All right, thank you guys for joining. Sticking around throughout the entire workshop. You also get a follow-up email with like links to this and the recording and everything too, once they all exist. So no worries there. Cool. Otherwise, thanks for showing up, folks. If you have any questions, you can throw them in the chat right Now, someone has at least one question about Python in general. So what was that? You're welcome, folks. If anyone has any questions about pretty much anything, I'll stick around. Any Python visualization tool to view plots when using a code editor? Using VS Code, we don't have any content. So if you're using this stuff in a virtual environment for Python, a few options, right? Matplotlib can save, I forget what the method name is off the top of my head. Matplotlib can save figures to image files. So if you really want to see things, you can write it to an image if you want to. It hits your disk and like is actually saved, but that's like a really quick, easy way to save a figure. Otherwise, in a notebook, graphs and charts will present themselves on a line, for example. These are just two quick series, and this is a quick Matplotlib scatter plot. So if you use Jupyter or Colab or one of the notebook softwares, like you can view them in line at least if you're just doing like quick exploratory stuff. And the charts will just show up here in memory, and you can keep, changing them around or something and seeing what changes and visualizing them. If you want to save them as images, I think there's like a plt.save or something that takes a file name and will save stuff for you as an image file. Yeah. Otherwise, how does this fit into data analysis? So for data analysis, so this is kind of the first step of data analysis, right? This is like the cleaning step, right? This is like cleaning and processing your data. Once you get to an analytical step, you can really use the same data frame of data to do what you want with it. This is technically data processing, not data analysis, the workshop, for a reason, because usually analysis involves a little more domain specific knowledge and some sort of like thing that you're looking for, like some outcome. At this point, you can use Python to analyze your data, raw Python. You can use Numpy or pandas to interact with your columns, do things with it, right? So it just kind of depends on your own creativity and I guess what you're trying to do with the data and how. So once you've prepared your data, right, and made it do whatever you need it to, doing the above methods plus whatever more you might need, you can take the data and do what you want with it. This is a quick example. As I was talking, I just copy pasted of like a chart. So if part of your analytical journey involves a chart, right, or charting, there's Matplotlib's a basic charting library. You can do this as a scatter plot. You can get any type of chart you would like, easy to complicated, using it to see trends and stuff like that. There's a lot of common statistical analysis is built into pandas, but especially NumPy. So for example, NumPy can even do some basic what may be considered to be like machine learning type stuff, depending on that, or at least advanced statistics, using your data. So sort of to answer that question, I guess, you can take the columns or the data from this data set, right, this data frame, and do almost whatever you want with it. This workshop doesn't really have time for it, but with students before, for example, I have used another library called scikit-learn to take this very data and create a player comparison model that essentially uses linear algebra to like take in a player name and tell you what player throughout history is most similar to them, right? So there's all kinds of like analytical Python libraries or tools or statistics you can use. It just at that point, it's very much more, right, creativity. Does that kind of make sense into how it fits into data analysis? I don't want to like leave your question hanging too much. But it just kind of depends on what you like need to do. Right, like these raw values are now ready to go into data analysis. You can either create the figures you want, or you can create the the output values you want, right? But that is a good question. What else? More questions from the participants. What do we got? Will there be more sessions for data processing? Currently, there are not any on the schedule. Although I am going to send out a quick survey as part of the links I send you that includes, would you be interested in a follow-up session at some point on a lot of this stuff? Or, you know, would you be interested in breaking this into multiple sessions or something? We've tried to break it into multiple sessions before. People usually were kind of hit or miss on that, just in terms of it being, you know, 3 classes, people show up to fewer of them, just the way it works. Yeah. But right now there aren't more on the schedule, though I'm always open on giving more, because there's a ton of depth here. It's required low preparation time and some interest. Otherwise, other questions? Y'all are here for a reason. Assuming you didn't know this stuff, I'm sure there's some question popping around in your head about it. You definitely have voice for at least another few minutes. What else? Questions in the chat? 18 of you are still here, so I'm sure you got something to ask. No problem. To all you saying thank you. By the way, if you don't have questions in the chat now, because I've clarified the link to classes next week. Yes. Not right now, but it will be in the follow-up email you get. I don't have it on me. The Monday intro to Python session you will get a link to. I promise that. Maybe even others too. There's at least one more coming up, I think. Yeah, so I'll be in your email with everything. I mean, realistically, with an evening workshop, if I send something in the chat that disappears, like no one ever uses it, so it's better to have it in your inbox where you can reference it tomorrow. Otherwise, other questions? Chat's open. I'm still here. It can be tenuous at this point. Like no one's, you know, you're not taking up anyone's question real estate. So anything else? If not, I will try to make sure Kai includes my email in that follow-up email as well. So if you have questions about getting started or issues or whatever, right? You might be able to do that looking for session on time series data. Interesting. Cool. That would be a useful and easy one, probably. There's a lot of stuff in here for time series data. So I might be able to look into that. Otherwise, anyone else? What else? No other questions? Then thank you guys for joining. Thank you, 16 intrepid few who are still on the call this amount later. At this point, I'm going to then mute myself, give y'all like another minute or two to jump off the call, and then I will also end the call. Again, check your inboxes for follow-up email with all sorts of resources. Otherwise, thanks for sticking around. I hope you learned something interesting.